Hi everyone, I'm Jaafar Hasan, a third year medical student, and today I'm going to explain about lung compliance. Okay, so to begin with, I would like to explain two main concepts or terms here. The first one is compliance. Compliance basically is a measure of distensibility of an object or a system. So the higher the compliance, the easier it is to cause distension of this object. And it can be calculated using an easy formula, which is change of volume over change of pressure. So if the compliance is high, we only require a small change in pressure to cause a large change in volume. One of the features of compliance is that it is inversely proportional to elasticity. So we have here two sets of rubber bands. The thicker ones have more elasticity, yet they are more difficult to distend. So the higher the elasticity, the lower the compliance. Now we can move on to the second concept we have here, which is functional residual capacity. It can be easily defined by the volume that stays in the lung after a normal expiration, not a forced one. So, and we have another way to calculate it, which is expiratory reserve volume plus the residual volume. So it is signified by this range right here. Now, moving on to this graph, in order to understand it well, we first need to define our axes. The first thing is that the y-axis is the volume, which is basically the volume of the lungs, and the x-axis is the airway pressure. We chose our reference point to be FRC because when the volume of the lungs is FRC, the lung and chest wall system has an airway pressure of 0. Now moving on to the features of the lung and chest wall separately. First, we can see that their slopes, which is the compliance here, because compliance is change of volume over the change of pressure. So the slopes are similar, so they have similar compliances. However, the lung has a collapsing force while the chest wall has an expanding force. Now, moving on to the lung and chest wall system, it has less compliance, that is a lower slope than both of them. And the volume, and at FRC, the airway pressure is 0. So it's at equilibrium. It has no intention to neither expand nor collapse. Now, moving on to the last concept of our video today, it is the effect of different pathologies on the graph that we've just explained. The pathologies that we're going to go through today are emphysema and fibrosis, and they are pathologies of the lung, so they don't affect the graph of the chest wall in any mean. They are exclusive to the lung. So let's start with fibrosis. Fibrosis basically means that we are changing the normal tissue of the lungs and replacing it with fibrous tissue. So this will of course decrease the compliance, and that's why here we have a line with lower slope, or which indicates lower compliance. Now moving on to emphysema here, we have higher compliance. Why? Because there is destruction of the elastic tissue. The lung, as we explained before, that there is inverse relationship between elasticity and compliance. So the higher the compliance, the less elasticity, and vice versa. Here we have low elasticity, lower than normal, so the slope is high and the compliance is high. And finally, let's move to the effects of these pathologies on the lung and chest wall system. As we discussed before, this is the normal line, and as we said, the volume at which the airway pressure is 0 is known as the FRC. Let's start with fibrosis. In fibrosis, as we discussed in this graph, the compliance of the lung is lower, so obviously this will affect the compliance of the system. Now it's even lower, and they have a lower FRC. The reason that they have lower FRC and not the normal FRC is that at the normal FRC, as you can see here, it intersects here, so there is higher tendency for the system to collapse. Now, moving on to emphysema, we say that they breathe at higher volumes. What does that mean? It means that their FRC is higher than the normal FRC. And that is because if we were to breathe at normal FRC while having emphysema, there is a higher tendency to expand, and which is, of course, it destructs or disturbs the equilibrium that we have. So that's why they have higher FRC than normal. And that's all I had for today. Thanks for watching and have a nice day.